Alright, so you should have added this to your notes, what the normal line's all about. Basically, normal line, same kind of idea as what we do with tangent line, except this is perpendicular to the tangent line. So, normal line is perpendicular to the curve at whatever the given point is. I want to practice that by taking a look at this problem together here. And for this first problem, I'm basically going to walk through it here for you, kind of see step by step how would we approach this. And then later on you'll be seeing more of these types of problems and seeing where you can do it on your own more and more. But for today, let's just walk through how we do it. Now first of all, what we can figure out from this information really easily is the slope. Because I have a nice pretty little equation there. It's a simple little polynomial. If I want to find the slope, that means I can find the derivative of it. So I'm going to look to see what does y prime equal. So I find the derivative of x squared minus x to the fourth. So that means I do the derivative of x squared, which is 2x, minus the derivative of x to the fourth, which is 4x cubed. And that equation will give me the derivative, which is the slope of the tangent line at any point I plug in for x. Now in this case, I'm interested in the point 1, 0. So I'm going to plug the 1 in for x. So I want to know what the derivative is when x is 1. And so basically that ends up being 2 minus 4, and 2 minus 4 equals a negative 2. So the slope of our tangent line is negative 2 at the point 1, 0. All right, now that I know that, I can now go ahead and start figuring out the equation, because that's what I'm asked for, the equation of the tangent line. Now, the tangent line, I know it's going to be y equals a negative 2x plus b, and b is what we have to figure out. Remember, in order to figure that out, I'm plugging in the coordinates of a point in for x and y. And I happen to know the point 1, 0, so I'm going to use that. I'm going to go 0 equals negative 2 times 1 plus b. Negative 2 times 1, of course, is negative 2, and so I'm going to add that 2 to both sides. So I end up finding that 2 equals b. Therefore, the equation of the tangent line is y equals a negative 2x plus 2. And there's the equation of the tangent line. We're going to repeat the same basic process for the normal line, where I'm going to start with the general equation y equals the slope times x plus b. But what is the slope of my normal line going to be? Well, for this we need to go back basically to geometry days, because you probably haven't had to use it much since then. The slope of perpendicular lines are opposite reciprocals. That is, flip the sign and flip the fraction. So like my original slope here was negative 2. I went the perpendicular to that. So I first flip the sign, so my negative becomes a positive in this case. And then I find the reciprocal of 2, which is 1/2. And so the normal line slope is 1/2. So again, if you want to add that to your notes because you had forgotten it, perpendicular slopes are opposite reciprocals. All right, and now that we've gotten to that point, we can figure out the b value the same way as we did the last time. Plug in a point. 0 equals 1/2 times 1 plus b. And the 0 and the 1, remember, that's the point that they happen to go through. All right, and so then I subtract the 1/2 from both sides. That gives me a negative 1/2 equals b. Therefore, y equals 1/2 x minus 1/2. And we are bouncing between a few different topics today, so I'm bouncing onto a slightly different one here. We will be coming back to tangents and normal line equations later. So for this one, we're looking to see when would this graph have a horizontal tangent. Now we don't have to make the whole graph, thankfully, for that. But we should still be able to figure out when it has a horizontal tangent, which, by the way, is actually going to be a big deal later, being able to figure out where these horizontal tangents occur. But for now, let's just see how we go about it. Well, first of all, if I'm dealing with tangent, that should be telling me right away, whenever I see that word tangent, that I should be dealing with derivative. And so, in this case, I am going to be dealing with derivative. And so that's the first thing I want to do. I want to figure out what is f prime of x. Well, hopefully finding the derivative of f of x is fairly straightforward here. Because the derivative of e to the x is e to the x. And then the derivative of 2x is 2. So f prime of x equals e to the x minus 2. Alright, now having done that, I can now use this to figure out where it has a horizontal tangent. Now, what's the slope of a horizontal tangent? 0. Yep, because that's why it's horizontal. Horizontal means slope of 0, so now I can set my equation up as 0 equals e to the x minus 2, and I can solve that equation. So, go ahead and solve that through. And so to solve this, I add the 2 to both sides first. So I'd have 2 equals e to the x. And now I need to solve that. And what do we use to solve e to the x equals something?
Natural log.
Natural log, yeah. And so I turn this into a natural log. So x equals, that's not a very good equal sign, equals the natural log of 2, which we then can actually calculate. Now if you dug out your calculators and plugged that in, you would find that x is about 0.693, and it's a decimal that of course goes on forever and ever. But we get about 0.693. So at that particular x value, that's where we end up finding that the tangent is horizontal. Right, now I want you to practice that same idea that we just did on finding the horizontal tangent for this equation. I've given you the general equation of a quadratic here. And yes, a, b, and c are all constants. So the first thing you should be doing is finding out what the derivative equation is. And so our derivative equation ends up being 2ax plus b. And then remember, we're looking to see where the tangent is horizontal, so it's going to be 0 equals 2ax plus b. And then you need to be solving that now for x. And yes, your equation will have lots of like letters and numbers in it. Alright, so if I'm going to solve it from here, I'm going to start by subtracting the b from both sides, so that gives me negative b on the left equals 2ax. And then I need to get the x by itself, both the 2 and the a are multiplied by it. Now, some people end up dividing by 2 and then dividing by a, but it's much easier, just divide by 2a. You can divide by both of them all at the same time. And if we do that, we end up getting negative b over 2a equals x, which hopefully seems a little bit familiar. Because you may recall back in the day when you were learning quadratics, Algebra 2 specifically, you were given this general equation and told, hey, if you want to find the vertex of a quadratic, there's this cool little formula, x equals negative b over 2a. And it tells you the x coordinate of the vertex. Well, the vertex of our quadratic, that's where the slope is horizontal. And so we just actually figured out how can we know what that formula is, because we just showed how can we figure out for any quadratic where that slope is horizontal. So that's where that little formula came from. Then another little jump here to a slightly different topic. I'm bringing back the El Capitan problem. Again, I just like it because it's a nice, pretty 3,000 feet tall. And we have the original equation here, h of t equals that, okay? And earlier we already found that the velocity equation, which is the derivative was negative 32t. So now I'd like you to please find the derivative of that equation. So find v prime of t. And so v prime of t, well, that's the derivative of negative 32t. So you should end up getting negative 32. That's the whole equation. V prime of t equals a negative 32. Now, what does that equation actually mean? Well, derivative, remember, gives us a rate of change. And so if I'm finding the derivative of velocity here, that tells me it's how quickly the velocity is changing. How quickly is it speeding up or slowing down or whatever it is. What do we call that idea? That's acceleration. Acceleration is how quickly or slowly you're speeding up, slowing down, whatever it is. And so then v prime of t can be written as a of t. And I'll give you some formal notes on that here in a moment. But basically what this shows us is that if we find that derivative of velocity, which was the derivative of the original position function, it tells us what the acceleration was. And this actually goes way back when we first saw this problem come up. I told you up front in that case that acceleration due to gravity was 32 feet per second squared. And it's constant. Notice it doesn't change based on how long it's been falling. It's always accelerating at the 32. All right. Now these are formal notes on that same idea. This should go into your notes. The whole idea here is that you start with some position graph. Here we're using s of t, but you can also see it as like height or distance, displacement. It can be used with lots of different words. The derivative of that's velocity, and the derivative of that is acceleration. Now I want to practice some of those ideas with this problem. So we have a height in meters. So notice we're switching over to meters, not feet. So it's no longer going to be the same 32 as we had before. A coin dropped from the top of the Leaning Tower of Pisa has an equation h of t equals 56.7 minus 4.9 t squared. So first question is, what is the height of this tower? And we can actually know it just from that equation, because the coin is being dropped from the top of the tower, right? And so when we first drop it, it must be at the top. That's t being 0. If t is 0, what's the height? (56.7 meters). And so you notice that number that doesn't have any t with it, generally speaking, that's our starting height. If this is an h of t equation, or starting position, if it's a different type of equation. Now, second question, what is the acceleration due to gravity when we're measuring here in meters per second squared? Well, I have a position function here, h of t. What do I need to do to that to find acceleration? Well, we need to find the second derivative. And so what you're going to need to do then is, in order to figure out what a of t is, that means you're going to have to figure out what h double prime of t is. So figure out the second derivative of that original equation, please. So to start, we figure out what is h prime of t. That gives me negative 9.8 t. And so then I can find the derivative of that to find acceleration, which gives me a negative 9.8. And so acceleration due to gravity in meters per second squared is negative 9.8 meters per second squared. Yes, that is a constant. Negative when we're looking at actually falling downward as being in negative direction. Sometimes you see it written positive, depending on what the equation is actually representing and measuring at that point. Now, one of the things that we've been talking about here in all of these is that the derivative, which we use to find the slope of the tangent line, we use it to find instantaneous velocity, we found it to find acceleration. All of those are different types of rates of change. So I would put into your notes some big idea there so you can look back and remember that derivative always means a rate of change. When you start seeing those two ideas as interchangeable, your life starts getting a lot easier when you deal with application problems. Because derivative is just the mathematical name given to the rate of change function. If you've not already written product rule into your notes, you can write it down from the screen here. It just might look a little different because it's being used with d over dx notation instead of prime notation, but both notations will work. And so where you first saw it with actual functions in there, today we're going to look and see what is it when we actually have some numbers. So we're going to figure out what r prime of 2 and r prime of 0 are based on this table of values. And so let's walk through that first one together and see how we could actually use this. First of all, notice r of x is defined as g times f, or f times g up here. Now that means I'm going to need to use product rule. So r prime of 2 is going to equal, it's going to be f of 2 times g prime of 2 plus, now we go the other way. So now we go g of 2 times f prime of 2. Now that's the same thing you would normally do with the equations, just in this case we aren't finding actual derivatives of the equations, we're given those values. And so r prime of 2, so that tells me I'm using the x column, the x row where we are at 2. I'm going to find what f of 2 is. So f, go down to the 2 row, so that's going to give me a negative 2 there. And then that's going to be multiplied by g prime of 2. So I go to the g prime column, and I go down to 2, and I see g prime of 2 would be negative 1. Then plus, and we repeat the process for g of 2, which if we look down the column is 0, and f prime of 2, which we can look down and see is 5. So negative 2 times negative 1 is a positive 2. 2 plus 0 is 2. So r prime of 2 happens to equal 2. I want you to practice this now. Please figure out what's r prime of 0. Alright, so when we find r prime of 0, you should be getting an answer here of negative 6. Again, just by using that idea of product rule where we have to do function times derivative of the other function plus derivative times function. And then finally, we're going to take a look at this problem. And we're going to see how we find the derivative of this. Now, this is the type of question that you were seeing on that first introduction. And this is a way we can just make sure you got the idea down. So I need to use product rule in order to be able to find this derivative, because notice I don't have any other way of finding that derivative. It's not x cubed plus e to the x. It's x cubed times e to the x, and that makes all the difference in the world. So In order to do this then, I need to first see what are the two types of functions that are being multiplied here. And notice I have this x cubed here, and I have the e to the x here. So those represent basically that f and g from the original equation. Now, in this case, it's possible that you could get thrown off because it's f of x equals, and in the equation it's f times g and all that kind of stuff. It's not the same f. All right, so in order to figure out the derivative of this, f prime of x, I'm going to need to do the derivative of 1 times its original, and the actual order doesn't necessarily matter because you're just adding them. So I always start by doing the derivative of the first one. Don't know why, just do today. All right, so the derivative of x cubed is 3x squared, and then that gets multiplied by the original other function. That's the e to the x. So that just stays e to the x. Plus, now in this case, the x cubed stays the same, and I find the derivative of the other function. That's the derivative of e to the x. Although it just happens that the derivative of e to the x is e to the x, right? That's it. Now we could get fancy here by trying to factor out an e to the x or something like that, but we don't need to. We can go ahead and leave our answer just like that. That is your derivative using product rule.